Hi, my name is Ewan and today I'll be giving you an introduction to quadratic equations, which is a GCSE level mathematics topic. Now, what is a quadratic equation? Well, a quadratic equation is a function which contains terms up to x squared. Therefore, we can express it colloquially as a term y equals ax squared plus bx plus c, where a, b, and c are any integer, positive or negative. So the only value that a cannot be is 0. The reason for this is because if a is equal to 0, then we have 0 x squared terms, and we do not satisfy the definition of a quadratic equation, which must contain terms up to x squared. B or c can be equal to 0. As long as we have an x squared term, we have a quadratic. Now, when we have quadratics, what we like to do is factorize them. Factorizing them is essentially taking our standard form of ax squared plus bx plus c and turning them into these brackets of x plus some integer, close bracket, and then open bracket, x plus some integer. Here we've got x plus d, x plus e. Now, just to show that this is possible, it's a lot easier to times out our brackets first to show that we can go from this format to our quadratic formulae. So in the example of x plus 2 brackets, x plus 3 brackets, we can do x times x gives us x squared, x times 3 to give us 3x, 2 times x gives us 2x, 2 times 3 to give us 6. Now here we see that we've got two x terms here, which we combine together as 2 plus 3 to give us 5x. Now therefore we can say that x squared plus 5x plus 6, our standard form, is equal to this factorized quadratic of x plus 2 open bracket x plus 3. Now as previously mentioned, it's a lot easier to go from this quadratic equation, from these brackets to your quadratic equation by timing out the brackets. But a lot of the time we have to go from our quadratic equation to these brackets. You'll understand why a little bit later. So in order to do so, we've got to follow some rules. Now as an example, in our standard form we have 2x squared plus x minus 6, which as you can see, a would be equal to 2, b is equal to 1x, and c would equal to minus 6. Remember the minus. Now, the first step is to use our sum and product rule. The sum and product rule essentially says we need to find two numbers which satisfy multiplying together to give a times c, and summing together to give b. So the first thing we do is we find ac and we find b. So ac, as before, we take a times c, which gives us 2 times minus 6, giving minus 12. Whereas summing to b is whatever b is, which in this case is 1. So if we times, as we've worked out here, minus 12 and 1. So what we would normally do is we'd go through a lot. If we couldn't find it off the top of our heads that are two numbers which satisfy this equation, which is normally can be quite difficult to do. And in this case, it's a big number and a small number, which makes it a little bit harder. However, if we were to do so, what we would do is we write down all the different combinations we could get to make minus 12 of these two numbers times together, and all the different combinations of two numbers that sum to give us b. So for example, we do 1 times minus 12, minus 1 times 12, or 1 times minus 12 to give us minus 12, then 2 times minus 6, minus 12, etc., etc. But in this case, we know that 4 times minus 3 gives us minus 12, and 4 minus 3 gives us 1. And there we have our two values. Now, the second step we must do is because these values sum to give us b, we can now split b into these two values. So in this case, we've split b, which was originally 1, into plus 4 and minus 3, which, as we showed, sums to give 1. Therefore, this equation is mathematically equivalent to the starting equation we had of 2x squared plus 4x minus 3, giving us 2x squared plus 4x minus 3x minus 6. Now, step 3 is we take our equation, which we had, of 2x squared, we'll go back so you can see it, the one that we've created of 2x squared plus 4x minus 3x minus 6, and we factorize the two halves. Now what this means is we take out a common factor of the two halves of the equation. So we take this value here, just to show you on the same page, to make things a little bit easier. We take our 2x squared and our 4x, one half of the equation, and our minus 3x and our minus 6, the other half of the equation. We look what common factor these both have. In this case, if we can take out, there is x common in 2x squared plus 4x, so we take the x out. And there is a 2 common, because 2 goes into 2, and 2 2's go into 4, giving us 2x, open bracket, x plus 2. Now on the other side of the equation, what we can do is we notice that there is only one x, so you can't take the x out. However, one thing that stays true for both is there are 1 minus 3, that sounds weird, 1 minus 3 can go into minus 3, and 2 minus 3's can go into minus 6. Therefore, again, we have a common factor of x plus 2, which we can take out of this side, as we see here. If we times them out, just show you the same, minus 3x, and minus 3 times 2 is minus 6. Minus 3x, minus 6. First half, 2x times x, 2x squared, and 2x times 2 is 4x, which gives us our entire equation. Now, as we can see, this x plus 2 is common throughout both halves of the equation. And in doing so means that we can actually take this bracket, this x plus 2, and multiply it by another factor, which is this 2x minus 3. Reason being, if this is essentially the same as timesing 2x, this equation is essentially the same as timesing 2x by x plus 2 and minus 3 by x plus 2. As we showed before, if we times them out, we'll get the same answer. Now, as I wanted to show you before, the reason we actually go and make these, we factorize these quadratic equations, is because that allows us to actually find some cool values. So, giving a real-world example of this, which is quite nice in quadratics, because we can actually see where maths applies to the real world instead of in a lot of cases with differentiation integration. It's quite hard to see straight off the bat. But in the real-world example of throwing a ball, we can actually model the height in which the ball has from being thrown to when it hits the ground as a quadratic equation. Don't worry, you won't have to actually derive this quadratic equation at any point, but it's just nice to see. And when we actually come to factorize it, it's something we need to do in GCSE. So what we can take from this question is, a ball is thrown straight up from the ground, from 3 meters above the ground, with a velocity of 14 meters per second. Now, the things we need to note are that the ball starts at 3 meters above the ground, it has a velocity of 40 meters per second, and it's thrown straight up from the ground, therefore it's affected by gravity, so it comes up and it comes down. So whereas before we used y and x in our quadratic equations, y and x can be any variable. They are only termed as y and x in our standard quadratic equation, just to hold the place. Now, if we have, in this case, we can say that y is equal to a height and x is equal to a time, so that we can draw a graph of height on the y and x on the, height on the y and time on the x, which allows us to actually see the height of the ball throughout the time in which it is thrown. So if we go through and take out these values, we see that the height starts at 3 meters, so our height, h, starts at 3. Travels up to 14 meters per second, so it's 14 times t, as it's 14 meters, which is the height, times t, seconds. And gravity pulls it down. We can derive this from CVEP, but don't need to worry about it. But essentially, this gives us our equation. H is minus 5t squared plus 14t plus 3 when summed together. Now, the real-world example continued. What I was saying before is why we factorize to give us certain values is if we are to want to know when the ball reaches the ground, we know that it must reach the ground when the height of the ball is 0, because that is our reference point. 0 is the ground. So we take our equation, and just to make it look a little bit easier, and we equate it to 0, because this is height. This, as we saw before, h equals this, so this is equal to 0 when the ball is at the ground. So this is what we've written here. And just to make things a little bit simpler for ourselves, we quite like to make the squared term a positive number, just to work a bit easier. So as we know from from previous mathematics, whatever we do to one side, we do to the other. We times this side by minus 1 and this side by minus 1. Times this side by minus 1 gives us 5t squared minus 14t minus 3, and timesing 0 by minus 1 gives us 0, as does anything times 0. So the first thing we do, as we did before, is we rewrite the equation. 5t squared minus 15t plus t minus 3 is equal to 0. Then we factor the first and last parts of the equation. As we did before, the first half and the second half of the equation, we can pull out a t minus 3 from this side, and oh, that's already t minus 3, so we only take out a factor of 1. And then, as we know the common factor is t minus 3, we can take out t minus 3 and then put our other common factor in of 5t and plus 1, which essentially is mathematically the same as what we've written here and here. Now, this is where it gets interesting, because what we can do is we know that if everything in this bracket is equal to 0, 0 times this bracket gives us 0. Same can be said for the other. If t minus 3 is equal to 0, we have 0 times 5t plus 1, which gives us again 0. Now this is a little bit confusing at first, because it actually shows us that we have two values of t which can cause the equation to equal 0, i.e. can say the ball is at the ground. Now, the first one is 5t plus 1 equaling to 0, and the second is t minus 3 equaling to 0. Now, if we do a bit of equation rearranging, we find out that t is equal to minus 0.2 as we take over the 1, which gives us 5t is minus 1, and minus 1 divided 5 gives t equals minus 1 over 5, which is also minus 0.2. Or t is minus 3, which is a little bit easier, because just take the minus 3 over, and t is equal to 3. Now, so this graph you would essentially get from plotting, if you put in a value of t from, say, like minus 100 to 100 as step 1, so minus 100, minus 99, minus etc., etc., you would be able to plot each point on a graph, which would give you where the ball is and what the height of the ball is with respect to time, as we've shown here. So we start at 3 meters because that's how far it was off the ground. As the time progresses, it's thrown up, it reaches the maximum point, and then gravity pulls it towards the ground, reaching ground at this point here. Now, as we saw before, we have our two values of when height is equal to 0, which is minus 0.20, this point here, and 30, this point here. So by common sense, we're saying that if t is equal to minus 0.2, the ball was at the ground minus 0.2 seconds before we even threw it. Therefore, this never happened. So our common sense is to ignore it, as stated here. But at 30, it says that 3 seconds after the ball is thrown, it's at ground level. Therefore, the ball hits the ground after 3 seconds. So as a summary, we figured out the standard form of quadratic equation, which was y equals ax squared plus bx plus c. Then we also showed that it can also be written in this format. And then we went through the sum and product rule of how to get to this format. So I've left a couple questions just at the end to make sure that you can run over them in your own time and understand it a little bit better. I'll leave these slides where you're able to look back at them, take some notes, or if not, if you can't do that, you're more than welcome to take a screenshot of the homework and just do them in your own time. I'll be here with the answers next week. Anyway, thanks for this lesson, and yeah, I hope taught you some today. Cheers.